This is the electromagnetic can crusher. It's extremely dangerous, so you need to follow the instructions in detail. There are some warning labels on the device in case you forget. This is Ben Childs. He's going to describe what we did to build it and how to operate it.
Okay, there are two switches. There's a safety switch released through a 100K resistor, and this is the switch that actually operates the coil. The large capacitor charges the coil, which crushes the can. This is the charging mechanism here, and this is the high voltage charger, which requires some care.
Notice that we've grounded the chassis of the cart, and it's grounded to the negative terminal, which is the outside chassis of the capacitor. And we've grounded that to this high voltage supply, as well as the ground cable for the probe, which we're going to use to measure the charge on the capacitor, step down by 1,000 volts, so we can use an ordinary multimeter. This capacitor is a 20 kilovolt, 14 microfarad capacitor, oil-filled electrolytic capacitor. It's extremely dangerous. They use these for plasma discharge in plasma experiments. You must follow all safety instructions when operating this device. It, at a charge of 20 kilovolts, which is not the maximum that this can put out, but the maximum that can handle before it explodes on its own, it can produce about a 2,800 joule pulse through this coil, which, because there's inducing a magnetic field in a particular direction, sets up a back EMF in the can, which sets up a current in the opposite direction. And since opposite currents repel, we should expect a pinch in the center of this can, and the can to violently deform in the center, and perhaps even with this new geometry, separate during the pulse into two pieces. So, let's give it a go. Alright, this is a safety, which should always be engaged. I'm going to disengage it. Ready? Ready? Plugged in?
No, there's not plugged in. Another safety. Don't plug in the charger until you're ready.
This switch both connects the ammeter and also connects a drain circuit after the main power, which is this switch, is disconnected. In order for the capacitors in this not to stay charged and therefore keep these lines at a dangerous high voltage, after we finish charging the capacitor to as much as we want, I'm going to flip this switch down so that it's no longer storing charge in these capacitors, then disconnect this so that there's no backflow of current into the device before I turn it off, and then I'm going to flip this switch. So that's the disconnect port. Ready? As you're charging, this ammeter should display somewhere between 0 and 5 milliamps. You need to keep it below 4 or 5 milliamps in order to stay within the safety rating for the wattage of the components that are used. If you keep that probe looking either at that side of this capacitor or right on the head of the capacitor, you can see it charging. I don't know if you can see in the video, but currently it's around 2 kilovolts. So we're going to wait as each time I increase the current, the current flow is going to increase and then slowly decrease as the capacitor becomes charged. Also, as I do that, the voltmeter, which is displaying the output, kilovolts output, is going to slowly increase as the leads that this is connected to are matched more closely to the current that's flowing into that capacitor. So, again, like I said, take a look. Okay, so now this is fully charged.
When you depress the switch, make sure to depress it all the way because it'll jump the gap and make a spark, but it won't discharge the capacitor fully. So,
at this point, you need to warn anybody who's watching hopefully this shield will protect people from sparks that are sitting in the front row here, but especially the people nearby, they need to cover their ears because it is extremely loud. And that's why we have these. And also, most importantly, I'm going to stand not in the path of this can, just in case. Okay, ready?
ready?
And there we have it.
Oh no! Wow.
Crushed. And I always connect the safety switch just in case there was not a full discharge after the can, and actually probably before you switch fingers in there. And then at some point after that, when it's sufficiently drained, a few seconds to a minute later, then connect this safety, which is just a pure short that's not resistive. There we have it, electromagnetic can crusher.